Okay, now we can start class. DBT clear, voice clear.
Yes, doctor.
Okay. Today we are going to discuss lecture 9. Lecture 9 is the second lecture in chapter 4. We finished lecture 8. Lecture 8 about probability experiment, about sample space, how to find sample space. After sample space, we discuss about outcome. Then we discuss about event. We divide event to 4 types. Simple event consists of one outcome. Compound event consists of more than one. Then we move to certain event consists of all outcomes, which is equal to the sample space. Then we move to impossible event, which denoted by empty set. Actually, it is impossible event. This 4 type we discuss. Then we move to set to operation of event. Discuss about intersection, union, join, disjoint, complement event. Discuss all this. Then we move to probability. Discuss 3 type of probability. Discuss about classical probability. Then we move to empirical probability. Finally, discuss about subjective probability. This is all about lecture 8. Today, we are going to discuss a little bit advance about probability in lecture 8, lecture 9. By ending of this class, students supposed to be learn how to find probability of compound event, but now we are using additional rule. Last class, we know how to find probability of compound event, but this class, we are going to use additional rules. Also, find probability of compound event using multiplication rule. Also, discuss how to use multiplication rule. Finally, students supposed to know how to find conditional probability of event. I think it's gonna be interesting class. We already know this. We discussed about 2 events A and B are called mutually exclusive event or disjoint event if they cannot occur at the same time. No intersection between. Intersection equal by empty set. It's impossible to be occur together. Let's take example. For example, if we roll a die one time, then we're gonna get this outcome. Sample space consists of 5. It consists of 6 outcomes, which is 1, 2, 3, 4 to 6. If we define E1 like odd number, then odd number gonna be 1, 3, and 5. If we define A2 odd even number, then 2 and 4 and 6. These 2 events are mutually exclusive or disjoint event. Why disjoint event? Because E1 intersection E2 equal by, right? No intersection between these two events. Odd is odd, even is even, no intersection between even and odd. Probability of intersection equal 0. B of E1 intersection E2 equal 0. Probability equal value. Intersection of event equal set. If we ask about intersection of 2 events, then it is equal by empty set. If we ask about probability of intersection of two disjoint events, then it is equal 0. So just be care about this. If we ask about probability, then we ask about value. If we ask about intersection, union, complement of event, then we ask about sets. Clear?
Clear.
Clear.
Let's move to this. Here, if two event A and B are not mutually exclusive event, this means intersection exists. Intersection exists. For example, a student belong to group 20 and advanced English level. Yes, it is possible. It is possible. But a student belong to a science track and engineering track. Is it possible?
No.
It's impossible, right? So let's see how to find probability of A or B. A or B means A union B. A union B equal B of A plus B of B minus B of A and B minus B of A and B. This is the general rule, but we have a special case. If A and B are disjoint or mutually exclusive, then A intersection B equal B of A intersection B equals 0, right? This equals 0 from previous slides. This equals 0. So in this case, B of A or B equal B of A plus B of B, right?
Right.
Let's explain this in just trying to delete this. Okay, so let's take example to distinguish between disjoint and join. Disjoint, we agree no intersection. Join, intersection exists. Okay, let's take a small example. Rolling a die one time. Sample space is 1, 2, 3, 4, 5, and 6. Now let's divide two events. Let E equal number greater than or equal 3. Okay. E2 odd number. Odd number. Question is find P of E1 union E2. Rule is like this. B of E1 union E2 union or it's same equal B of E1 plus B of E2 minus B of E1 and E2. Let's see. B of E1 means B of what? B of number greater than or equal 3. Greater than or equal 3 is 3, 4, 5, and 6. 4 number, right? So it is 4 over 6 plus probability of E2. E2 is what? E2 is odd number. Odd number is 1 and 3 and 5, which is 3 over 6, right?
Yes.
Right.
Over 6.
So we get
Now,
7/6.
but now we are going to subtract the intersection of these two events.
2/6.
Yes.
Uh,
E1
3 and
is
5.
number greater than 3. So number greater than 3 and odd number.
Oh, so 3 and 5.
Yes, so it is 2 over 6. 2 over 6. It is 5 over 6.
5.
Yes. This in general. In general. Why in general? because probability of E1 and E2 exist. It's not by, not equal zero. Probability does not equal zero because these two events are joint event, right?
Right.
Let's take other example. Maybe we have example here. Let's take this example. We have, we roll a die one time, single die, find the following, getting odd number of or getting number greater than 4. Okay, so we have two events. This one, let denoted by A, and this denoted by B, and it is OR. So we have rule for OR. It is B of A or B equal what? Equal B of A plus P of B minus P of A and B. A and B. Okay. B of A equal, A is what? A is odd number. Odd number is 3/6, right?
Right.
Plus B of B,
Greater than 4 is 2/6.
yes, which is 5 and 6. So minus intersection exists. A number odd and greater than 4 is
1/6, 5.
5.
yes,
So it's 1/6.
1/6. So it is 4/6, right?
4/6. Yeah.
4/6 is 2/3. 0.667. This is about first question. Let's move to the second one. Second one is about to even odd number or getting number greater than 5. Okay, this is first event. This is the second one. So we use same formula because we are talking about OR. For OR, we use this. Odd number is 3/6, right? Same. Getting number greater than 5. Greater than 5 is
1/6.
6.
So it's
1/6.
1/6.
Yes. Now we are going to what? We want to check the intersection. Odd and greater than 5.
There is
0.
no
No
intersection.
intersection.
So it is 4/6. It is still same, which is 2/3. So for this event, this disjoint event, mutually exclusive event. This event, why? Because intersection equal 0. So in this case, we use B of A or B equal B of A plus B of B. Because actually this equals 0, right? So we just do addition. So we call this addition rule. Why addition? Because we only add probability of A plus B plus probability of B. In general, if we have A and B and C and D and so on, all are mutually exclusive event or disjoint event, then B of A or B or C or D and so on equal summation of these probabilities. Clear?
Inshallah.
Even if not clear, still we have a lot of example we can see. Don't worry. Okay. Here we have two examples. We already solved this, right? It's already done. Okay. Here we have student final grades in statistic are shown below. So we have student grades A's, B's, C's, D's, and F. Student gender, male and female. We have total of student get A's, total of student get B's, C's, D's, and F. And we have finally total of all students, a total of male, total of female, and total of female, total of male, total of female, and grand total. This total all total number of students. Here we divided to F, D's, C's, B's, and F. Okay, we selected one student randomly from this college, say, or this school, for example. And if a student selected randomly from this, find the following probabilities. He is male, or a student. We use same formula, B of, let this first event and this second event. So we find probability of what? According to rule, it is B of male, right? B of male plus B of a student minus B of both. Both means what? Male and a. Male and a student. So B of male, we go to male, this row, male. How many male students?
230 over
Yeah.
520.
Yes, over
520.
plus B of A's, I go to this column. B of A student is 63 over grand total 520 minus B of intersection of male and A. Male and A is
20.
20 over 520 equal 273, right?
Yes.
Yes. This is the probability of selecting one student, and he is male or a student. Clear?
Clear.
If we select one student and find probability she is male or C, same idea. We go to find B of male plus B of C student minus B of male and C. Sorry, female and C. So it will be like equal B of female is 290, right?
Yes.
Plus B of C. We go to this column. 172 over 520 minus B of intersection. Intersection of what? Intersection of female and C. This 94 over 520. Is it clear?
Clear.
Okay. If we ask, find probability of B of A students and B students equal A and B equal
63 over 520 plus
and
56.
يا محمد and
Okay.
so and equal
Intersect.
so intersection exists?
No.
No intersection
Yes.
between rows, no intersection between rows, no intersection between column, but intersection between rows and column. For example, A and male, yes, exist. B and female exist. But male and male, no, it's disjoint. Male and female, disjoint. A and B, disjoint. B and C, disjoint. C and D, disjoint. So no intersection between column, among column, no intersection. Among rows, no intersection. But column with rows, yes. Clear? Here, if we ask about or, yes, you are right. A or B. Now we come to add how many students with A? 63. How many students with B? 163. So in total is 193 over 520. It's clear?
Clear.
Okay, let's see. Next, already solved this. We already done, right? Probability of male. First, we have to find probability of male. B of male. This is B of male. Then we find B of female. B of male. B of student with A. Intersection is 20. So we add B of male plus B of A student minus B of intersection male and A, which is 273 over 520. We do similar female or C, just we find B of female plus B of C minus B of both equal 0.707. It's clear, I think. Now we are going to, before this, maybe we can take other example. Let's take other example. If, for example, if P of A equal 0.6, for example, B of A or B equal 0.9, okay? If A and B are disjoint event, find P of P. How to find B of V? Actually, they give us three value or three information. B of A given, B of A or B given, and also we come to know A and B are disjoint event. How to find B of P? How to find?
وسبتكرات B of A and B of A or B.
So B of P equal
0.3.
Yes, great. Just like this, I know B of A or B equal B of A plus B of B. Why plus B of B? Because these two events are disjoint. We just do addition. We call this addition rule. So already this is given. This is 0.9. So 0.9 equal, this also given. This is 0.6 plus B of P. So just by subtraction, B of P should be equal 0.3. Yes, great. This is like clear example. Now we are moving to other type of, maybe we hear this example of No, this example of independent, but also we have some example about mutually exclusive event. Getting odd number, getting even number. Of course, this is mutually exclusive event. Getting a tree and getting odd number. No, this is not mutually exclusive event. Why? Because intersection exists. A number can be odd and tree. Actually, 3 itself is odd. Getting odd number and getting number less than 4. Yes, less than 4 can be 1 and 3. So intersection exists. So this is not mutually exclusive event. Getting number greater than 4 and getting number less than 4. Greater than 4 cannot be less than 4. So it is mutually exclusive event. Clear?
What does that mean, doctor?
That means these two events cannot be occur together. If two events cannot be occur together, we call them mutually exclusive event. Example, a student cannot study in two track. A student cannot study in two college. Right? This mutually exclusive. A student, we selected one student, cannot be male, cannot be female same time. Right? A student cannot get same grade in one subject. You get A plus and B in statistics. No. So we call this disjoint event. Disjoint means no intersections. We already discussed this, right?
Yeah.
If two event, disjoint event, then probability of A or B equal B of A plus B of B. If three event, A and B and C, are disjoint event, then B of A or B or C equal B of A plus B of B plus B of C. Clear?
Clear.
That's why we call this addition rule, because we just add. We don't do subtraction. Now we are moving to other called multiplication rule. Multiplication rule we use if we have if two events are independent. Two events are independent. How I come to know these two events are dependent or independent? Two events independent if the occurrence of A does not affect the occurrence of the even B. بالعربي كده وقوع A لا يمنع أو يؤثر في وقوع B. In this case, B of A and B equal B of A multiplied by B of B. For example, let's take example B of say Ali get success in statistics is 0.8. B of Umar get success in statistics is 0.7, for example. Probability of both of them get success. Probability of both
0.56.
Yes, we just do multiplication, 0.8 multiplied 0.7 equal 0.56. Why? Because probability of Ahmed's success definitely independent of probability of Ali's success. So in this case, we just do multiplication. In general, if I have A1, A2 to A, I have A, B, C, D to K event, all of these are independent. I just do what? I just do multiplication of this event. Probability of A and B and C and D equal B of A multiply B of B multiply B of C to B of K. Clear?
Clear.
Here we have example of some independent event. Getting success in statistic course and getting fail in computer skills. Definitely computer and statistics independent. Getting hit when tossing a coin and getting two when rolling a die and tossing a coin independent. Having A plus plot type and getting A plus in mathematics, of course, both are independent event, right? Let's take example. Here we have example. Family consists of 4 children. Question is find probability that all children are boy. Before this, let's take easy example. A family consists of, let's say, 2 children, only 2. Sample space, how many outcome in sample space? 2 children. 2 children means 2 power 2. Why 2 power 2? Because we have two outcome, boy or girl, right? Boy or girl. And how many trail we have? Trail of getting baby, 2. So it is 2 by 2 is 4. So we have 4. This 4 may be both boy, maybe first one boy, second girl, maybe first girl, second boy, or maybe both of them are girls. So this all possible outcome we have. Now, if we ask find probability of both are boy equal, both are boy means what? Boy and boy. Boy and boy equal P of boy and boy equal boy and boy equal
1/4.
equal 1/4. Why 1/4? Because number of point in sample space is 4 and BBB is just simple event, 1 point. So it is 1/4. So now let's make it easy. How easy? B of B, B in statistics we don't write and, but actually it is B and B. B and B. B in first and B in second. This equal what? Let's check, is it independent event or not? Independent. Does second baby depend on the first baby or not?
Yes, it does.
No, it is independent. If first baby is boy or girl, does not affect the second baby. Second baby also can be boy, can be girl. This is independent event. Independent event. So B of B and B equal B of B multiply B of B. Multiply B of B. B of B equal half. So in each trail of getting baby, we have half. My B baby, my B girl, my B boy. So it is 50%, 1/2. Multiply 1/2. It is 1/4. Same like this. But here we need to write sample space and then come to compute. It is easy. Just each trail of getting baby is half. So 2 baby is half by half. Okay? Now, if we have a family consists of 6 children, 6 children, find probability of all of them are boys. All of them are boys means B and B and B and B and B and B. 6 boys equal, we use same ideas. B of B, multiply B of B, multiply B of B equal half
1/36.
1/, half power 6. Half power 6 is 1/64. Clear? Half by half by
Clear.
half by half 6 times. Let's see now, maybe it is easy to understand the example. This example, family consists of 4 children. 4 children, find probability, all of them are boys, which is B of B and B B and B and B and B equal B of B, multiply B of B, multiply B of B, multiply B of B equal half power 4, which is 0.0625. Clear?
كلام.
Clear.
So here we have example. Assume the probability that a student pass the test of mathematics is 0.71 and probability that the student pass the test of statistics is 0.66. If one student selected randomly, what is probability that the student pass the test of math and statistics? Passing math and passing statistics actually are independent events. So probability of passing both equal probability of passing math multiplied by probability of passing statistics. So it is 0.7 multiplied 0.66, which is this. This logic, student can pass statistics with 0.71. Student can pass math with 0.60. Pass both, of course, will be less than each of these, right? So this example of probability of independent events. We take break and come back after 20 minutes. So before class, we discuss about mutually exclusive event, discuss about addition rule. Now we are going to also discuss about independent event, rule 1. Now we are going to discuss about dependent event. If we have two events are dependent, let's take example of dependent event. Suppose we have books contain white ball or red ball. If we have five white, let's say 7 red, okay? Just I want to explain to you dependent and independent event because we have two rules. If we take 2 ball from this box, question is find probability of these 2 ball are white. First white, second white. If we do selection drawing with replacement, means I take and replace back to box. So is it independent or dependent? If we take and replace, B of first ball white equal 5/12, right? First ball white, we have 5 white ball. Total number of balls are 12, so it is 5/12. Second ball, if we return back, we replace back, still 5/12, right?
Yes.
Right.
So this is independent. So if we take and we didn't replace back, then first is first. First is always independent. Second depend on the first because we take and we did not replace it back. So it's gonna be we take first ball. It was white. We throw it out. Now we have how many white ball?
11.
Yes, because we have 4 white ball. Now actually we have 4, only 4 over 11. 4 over 11. Is it clear?
Clear.
Right. So this is dependent event. This is independent. Now we are going to construct general rule. If A and B independent, then B of A and B equal what? Equal B of A multiply B of B. We already discussed this before. If A and B are dependent dependent in this case, like this. For this is dependent. B of W1, W2 equal B of W1 multiply B of W2. So if A and B or W1 and W2 are dependent, then B of A and B equal what? Equal B of A. B of A is always independent, first event independent, multiply with B of what? B of B, we write it like this, we read it given B, given A, given B of A, given B. This means what? For example, B of W1, W2 equal what? Equal B of W1, W1 this one, multiply by B of W2 given W1. This means what? Means probability of W2 if we know W1 is white. Because I have to know first ball, is it white or red? Here, because first ball is white, we subtract 1 from white. So it becomes this 4. And total also reduced to 11. So it is 4 over 11. This is the second type of multiplication rule. We do multiplication, but in this case, we have to know the first event. Is it red or white for our example? Let's see. Let's see example from, this is example of dependent event. Drawing a ball and not replace it back, as we do in our example. Driving on ice and having an accident. Yes, if you drive in ice, maybe you gonna have accident. Smoking extensively and having lung cancer. Yes, these two much related together. So for this case, we use this formula. If two events are dependent event, then B of A and B equal B of A multiply B of B given A. B of B given A means one. Means B of A, if we already know A is already occur, A already done. Clear?
clear,
Let's take this example. This example, almost same example. Box contain 5 red, 7 white. We draw 2 ball. Find probability. First ball is red. Second ball is white. If drawing with replacement. With replacement means what? This
يعني رجعناهم.
yes. So if we do replacement, then it is independent, right? Independent. So in this case, we just find probability of first ball red multiply probability of second ball red. First ball red is 5 over 12.
12
Multiply by
times 7 over 12.
7 over 12. Yes. It is 35 over 144. Okay. Same question, but without replacement. Without replacement. So without replacement, these two events are dependent. Dependent event. So in this case, probability of first ball is same like before. First ball is red is 5 over 12. Second ball, we need to know the first ball. It was what? It was red. So now we subtract one red, come 4. So probability of white is still same, 7, but number of
Or
dots
11.
becomes
11.
so it is 35 over 132, right? Yes. Clear? Clear? So we have other examples
Clear.
about dependent event. Suppose 45% of the students are male, say in school. 78 of them have in driving license. If one student is selected randomly, find probability that he is male and has driving license. These two dependent events, let M student is male and D student having driving license. B of this is a question. B of a student male and have driving license is equal B of M, B of male, multiply B of male, B of having driving license, given he is already male. This is already given, already male, already 0.78. So just we multiply 0.48 by 0.78, which is 0.351. Clear? So now we are going to the last part of class about conditional probability. Conditional probability, maybe just we can explain before we discuss about dependent event, probability of first white, second white, equal what? Equal B of first white multiplied by what? By probability of second white given first white. This what? The second is white. We know the first is white. Now, if we ask to find this, find probability of second ball is white, given first ball is white. How do we get this? This equal what? Use same this. This is math, not statistics. If we ask about this, B of
Divide BW1 W2 over BW1.
So it's PW2.
yes, W1 W2 over B of W1. We call this conditional probability. Conditional probability. Probability of W2 given W1 equal probability of W1 and W2 both over B of W1. W1 already given, so we subtract over B of W1. Clear?
Subtract or divide, doctor?
Divide.
Uh-huh.
Divide over W1, not subtract. Divide over. We call this conditional probabilities. Let's try this using A and B. A and B in general, using A and B. B of A given B equal what? Equal B of A and B. A and B over B of
A.
no. B of B. Actually, we asking for B of A. We don't know B of A, but we know B of B. Okay, B already done. Done. خلاص finish. So we can use this. So B of A given B equal B of A and B over B of B. Similar. B of B given A equal what?
E, A, and B over A.
Yes. over B of A. Yes, good. Also, in this case, B of B should not be equal 0 by logic, because B of B already done. So it is not impossible event, right? Also here, B of A should not be equal 0. Okay? So now clear? If clear, we will ask you other questions. A little bit deep question. Exam question. Clear?
Clear.
Okay, let's move to one question. If A and B are independent, A and B are independent. A and B are independent event. We ask about find B of A given B. Equal what? Let's use same formula. Yes, let's use yes, this one, first one. Is equal B of A and B, right? Over B of B, right?
Yes.
Yes.
Okay, if A and B are independent, then B of A and B equal what? This multiplication rule. Remember multiplication rule? A and B are independent. B of A and B equal what? No, no. If A and B are independent, then B of A and B equal what?
I
They are
think
multiplied.
BA multiplied by BB.
Yes. So we have B of A and B equal B of A multiply B of B, right? Over B of B equal what? This equal B of A multiply B of B over B of B equal what?
P of A.
Equal B of A. Why equal B of A? By using this formula, we get it. It is F equal B of A. But actually from here, B of A given B, if A and B are independent, so B of A, B of B, B of A does not depend on B of B. Just we delete this.
They can independent.
Yes, just we delete this and get this. Clear?
Yes.
This is an example. In exam we use to give you if B of A equal 0.2. B of B equal 0.6, for example. A and B are independent. Find B of A given B. Direct. B of A given B equal 0.2. Why 0.2? Because we already mentioned A and B are independent event. So now let's see the examples. Yes, we have example here. The probability that married couple watch together a special television program is 0.6. Both of them together watch is 60%. Probability husband, one of them watch program 80%. Probability of wife watch 65%. Find probability that the wife watch the program given that her husband already did. First, how to write the question. If we write the question, then done. Okay, let husband get denoted by A, wife B. Okay, this both together means A and B, AB. Now we have intersection, we have B of A, B of B, B of A and B. Question is, what probability, just we come to write B, of what? That the wife watch the program, watch wife is what? Wife is B. Watch the program. Given that We write like this. Given that husband is A. So this equal what? This is a questions. This equal what? This equal B of both, صح? A and B over B of
A.
A.
B.
A. We ask about B. B of A here. B of A and B. A and B is both. Both is given 0.6. 0.6 over B of A. A is what? A is
0.8.
0.8.
0.8.
Yeah, so it is 0.75. So if we change this question to what is probability of husband? What's the program given that wife already equal
0.6 over
0.6 over point
0.65.
0.65.
yes 0.65. Great. Yes. So just writing the question in right correction give you the correct answer. It's clear, I think. Now we are moving to this same like before. Before example was about student grades and male and female. Question was find probability of male or C, female or D, right? Now we are asking about conditional probability. Conditional probability can be in same questions. If we go back here, we can ask you about if we selected one student randomly, find probability. If we select one student random, and I know he is male. What is probability he is F? He has F grade. Let solve this and go back to that question. We select one student, and I know he is male. Find probability he is F. We use same formula. This is B of what? B of both. Both is male and F over B of male. Okay, B of male and F. Male and F is intersection. Male with F. This 28 over B of male. Male is
The sum of F, D, C, B, and A.
male is male. This
توتال يعني total حق الميل 2030.
230. It's like this. But actually, B of male and F is 28 over this. Right? 28 over 520. B of male also.
قلنا ميل ليش نقسم على التوتال؟
B of intersection, B of male and F, this 28 over grand total. How many students with F and male? 28 students. Total number of students is 520. So we divide over 520. A B of male, how many students with male? How many students male? 230 over total number of students 520. But actually we delete this with this and we get simply 28 over 230. Clear?
Clear.
We go back to that question and try to use same procedure to solve. Here, this we have 2 by 2 table. Satisfied surgery operations for 350 patients. We divide them to some of them satisfy, some of them dissatisfied, to surgery, knee, ankle operation. So we selected one student from here. We come to know that fine probability that person had ankle replacement surgery, given that he was satisfied. Okay, first, how to write the questions. How to write the questions. How? Find probability, so it is B. B of
Yes.
what?
P of this
A
classification.
D.
Let Okay, let's write this A to make it easy. A, B, C, D. Okay, so find probability person had, given that had
P, B, and D.
A
E given D.
given D, right?
B, not A.
B, not A, doctor.
Yes, B of B
P of B and A, yes, and D.
given D equal what? Equal B of
B and D
B and D.
over B of D.
Yes, over B of D. Okay, B of B and D equal B and D, B, this B
50.
and 50 over B of D. D is
150.
120. Yes, just like this. So it's clear, right?
Yes.
Now, if we can these questions, what is probability that this person is dissatisfied given he had ankle replacement surgery?
يصير
C given D. No, C given B
C given
over
So same question,
PB.
we make it B probability of D given B.
I think C given B.
It's C, doctor, not D.
Same question. It is same question. I just like exchange it, make it like instead of B given D, we make it D given B.
yes.
Okay.
يعني
So
we selected one patient and we know he is satisfied. He is
Okay, so
satisfied.
it's B,
Probability of
C
he
given
has,
B
yes,
over B, I think.
yes, which is
yeah.
50 over
50 over 200.
yes, 50
Yeah.
over 200. Always we divide over what? Over which is given.
Yes.
And this will be the both intersection of the both event. I think it's clear. Okay, let move to the second questions. Determine probability that person was satisfied given that person had ankle replacement. It is same question. We already solved, right? It's already done. It is same like done. Clear? Now moving to at least and at most. Let's explain this in easy way here. Suppose we have coin 2 times. Coin 2 times. Sample space, how many points? So sample space is 2 by 2. 2 by 2 is 4. Coin 2 times. So both may be H, first and second. First may be tail, second may be H. First may be H, second may be T, or both may be T. This all possible outcomes. So this is a sample space. So if we ask you to find probability of at least one edge, at least one edge means what?
3/4.
Yes, but means what? It is 3/4, right? 3/4 means what? Means P of 1 H plus B of 2H, right? At least one means one or more, right?
Yes.
So this we can do it in easy way. This just equal 1 minus B of what? B of none. None means all of these except this, right?
Yes.
So this is none. None means 0H. So it is 1 minus 1/4. 1 minus 1/4, it is same like 3/4. 3/4. Is it clear?
Clear.
So if clear, just let go to use same example, but coin 5 times. Coin 5 times. Same question. Find probability of getting at least one edge. Coin 5 times. Sample space 32 points. Find probability of at least one edge. At least one edge, as we prove, equal 1 minus B of none. None means all these. Equal what? Equal 1 minus. All these
1/32.
yes, 1/32 equal 31/.
1/5.
Yes. If we have 6 coin, or if we toss a coin 6 times, probability of at least one edge equal at least one edge equal what?
63/64.
Yes, exactly. Okay, great. So now we can move to slide to see. Now just discuss probability of at least, and then later we come to see probability of at most. Example, coin 6 times. How many outcome we have? 2 power 6. 2 power 6 is 64. 64. This already we know. 2 power 6 is 64. Now find probability of getting at least one hit. At least one hit. It is 1 minus 1/64. It is 63/64, which is this.
طب مستر عبد الله اللي
Yes,
قال لك at least 2 heads.
at least two. This too much good question. Who asked this?
عبد الله عبد العزيز.
Group 17.
Yes.
So you are back.
Yes, I'm here. I'm back.
Okay. So if ask about at least 2, at least 2 means what? At least 2 means when he asks about at least 1, we subtract 1 minus none, right? Right?
Yes. Yes.
Yes.
If asked about at least 2, we will subtract 1 minus B of 0 minus B of 1. Clear? Or not clear?
Not
But
what?
how do we get at least one head? The P of 1.
When he asks about at least 1, we subtract 1 minus none. None means what? 1 minus B of 0. Right?
Yes.
1 minus B of 0 when they ask about at least. At least what?
At least 1.
At least 1. 1 minus P of 1 minus P of 0 if asked about at least
2.
yes, at least 2. 1 minus P of 2 minus P of 1 minus P of 0 if they ask about at least
3.
yes 3. But for I think it's not easy to understand at least 2, at least 3. For at least 1, now we are trying to just explain to you how to understand at least 1. But these good questions, at least 2, at least 3, we subtract the complement actually. At least 2, from here we start, right? Right?
Yes. Yes.
Complement of at least 2 is what? 0 and 1. 0 and 1. So 1 minus this gives this, right?
Yes.
At least 1, 0, 1, 2. We start from here. So this is a complement. And so on. At least 3 from here. So this is a complement. And so on. This is the general idea. Good question. I think now it's become more clear, right?
Inshallah.
In exam, maybe we ask you about at least 2. But we explain to you at least 1. If you understand at least 1, you will go to understand at least 2. But now already we explained to you at least 2, at least 3, and so on. Clear? Okay.
Yes, Doctor.
This is a good question. Maybe I will give you a bonus. Asking
Thank you, much
question
appreciated.
also is not free. So ask. Let's go to explain at most. Do with same idea. Same idea. If we toss coin 6 times, then we ask about at least one H. We already solved this. At least one H. At least one H is 1 minus non-H. Non-H, which is 1 minus 1 over 64 was 63 over 64, as we seen in the previous example. Now, if we ask at most 5, at most 5H. Same 0H or 1H or 2H or 3 or 4 or 5 or 5 or 6. So at most means what? At most means this 5 or less. 5 or less. So a complement is this. This is a complement. Complement of is B of all R heads. So same idea. How to get at most 5? 1 minus what? Complement.
6.
None.
Yes.
1
minus,
over 6.
yes, 1 minus B of 6, which is 1 minus 1 over 64. It's same like 63 over 64. So this is the idea. We use complement. We use idea of the complement. Let's see the example here.
بتنزل سلايدات اليوم يا دكتور؟
What?
السلايدات هذه بتنزل اليوم؟
Yes.
إن شاء الله.
Inshallah. Yes, you already explained at most. I want you to understand the general concept, not the example. don't understand this example. This example to make you understand in general. Okay. For at least and at most, we use a concept of complementary event. Complementary. So at most 5, easy. Ask about at most 4. How to get at most 4? At most 4. Just fast one.
1 minus b of 5 and b of 6.
Yes. Yes.
يعني
Great.
يعني بتصير 1 minus 1 over 32.
No. Just now, for now, let me make it 1 minus. For next class, I think lecture 11, we're gonna understand it in details. But for now, it is 1 minus b of 6 hits minus our minus b of 5 hits. If they ask about getting atmosphere, clear?
Yes.
Clear.
So move to last slides. Probability of Zahra get scholarship 0.7. Probability of Nof get scholarship 0.6. Find probability of at least one of them obtain or getting the scholarship. At least one of them. This question at least means same concept of complement event type. Let D probability of Zahra get scholarship and F probability of Nof get scholarship. Now B of D 0.7 for Zahra, B of F 0.6 for Nof, B of complement. B of Zahra does not obtain scholarship is 0.3. 0.3. Complement of 0.7. B of Nof does not get a scholarship is the complement of 0.6 is 0.4. 0.4. So probability of Nof and Zahra does not get a scholarship. Both of them equal what? Both of them does not get scholarship.
0.4.
Probability of Nof does not get a scholarship is 0.4. Probability of Zahra does not get a scholarship is 0.3. Probability of both does not get a scholarship equal what? Is what? Is
Multiply them.
0.12.
yes, exactly. Because this is independent event. Independent. So it is 0.3 multiplied by point is both complement. Not Zahra and not Nov, both does not get a scholarship, so it is 0.12. So now we asking about at least one of them obtain the scholarship. At least one of them obtain the scholarship. At least equal what? At least the complement of what? At least means 1 minus none of them. 1 minus none of them. B of none. B of not Nov.
P of not getting.
Not Zahra. Yes, which is 1 minus 0.12 is 0.88. So 0.88 is probability of at least one of them will get a scholarship. Now we finish class. Still we have 8 minutes. We go to attendance.